Electricity is a very important energy form in modern civilization. Electricity powers innumerable different devices. Electricity is a very efficient energy form for reducing our workload, making tasks easier, and provide access to education and entertainment. Electricity helps us to become more productive and can increase the quality of life. With electrical lighting, we can maximize our time in doing useful things while also improving nighttime security and safety. We can learn and continue work during night and benefit from new forms of entertainment. Many parts of Indonesia are difficult to reach with a PLN grid electricity. Therefore, we need to find new solutions for the question of how rural community can be connected to electricity. Fortunately, Indonesia provides an abundance of natural resources that can be utilized for independent electricity generation. These include hydropower, solar energy, and biomass energy. In fact, Indonesia has much experience using micro hydropower, through which a rural community can get clean and reliable power. A micro hydropower plant, or MHP, is an electricity generator which uses a turbine and generator to convert water's kinetic energy to electricity. MHP plants usually range between 5 to 100 kilowatt of electricity output. An MHP's power potential depends on the amount of water flow and drop-off slope height. Water flow is measured in liters per second and height in meters. Height is also referred to as head. Water flows from a certain height with sufficient quantity to drive a turbine. The turbine is the mechanical equipment used in the MHP. Inside a turbine, we find a component similar to a propeller. When water hits the plates, the propeller starts to rotate and produce kinetic energy. The most commonly used turbine in rural Indonesia is the cross-flow turbine, which operates well with moderate head about 15 meters and flow requirements of about 150 liters per second. Beside cross-flow, other types of turbine are propeller and Pelton. A propeller turbine is good for low head of approximately 4 meters and a high water flow of 500 liters per second. The Pelton model is used for high head of around 50 meters and low water flow of about 40 liters per second. The MHP works by diverting water from a river or irrigation channel through an intake construction. From there, water is passed along the channel to a forebay and into a penstock pipe attached to the turbine. After passing through the turbine, the water flows back towards the river or irrigation channel. The rotating turbine is attached to a generator shaft to produce electricity. To calculate the generated power, the water density is multiplied by gravity force, multiplied by water flow, multiplied by height, and multiplied by efficiency of the turbine. The MHP construction is done by experienced technicians, ideally with community involvement. The first step is a pre-feasibility study for collecting preliminary data regarding water resource potential determining possibilities of MHP location and collecting socio-economic and demographic data of the community. From this survey, the principal technical requirements for the MHP and the village are determined. This includes topography and water flow. Rural areas' natural landscape, especially hilly areas, will provide bigger electricity generating potential from water. This is especially true in villages with sufficient water resources, whether from a river, irrigation channel or water spring with stable water flow in all parts of the year. All-year water flow stability means that even during dry season the water level is sufficient to generate electricity. Distance between powerhouse to households are also considered. Ideally, the powerhouse is built close to the hamlet or village. Powerhouse distance should not exceed 2 kilometers from customer area, so that the customer grid does not become too expensive and electricity quality can be ensured. If the pre-feasibility study yields positive results, the next step is to conduct a full feasibility study. During this feasibility study, more detailed measurements are taken with different equipment. During the feasibility study, electricity distribution infrastructure is also mapped to estimate transmission and distribution cable distances. Data from this survey will become a basis for detailed engineering design and budget plan. Following the feasibility study, a detailed MHP construction design will be produced. According to the design, civil structure construction, turbine construction and customer grid installation will be done. Good construction with standardized equipment will make the MHP last longer and perform better. From the planning stage until the MHP is installed, community involvement is needed. Community involvement is important so that the community will be prepared to manage and use the MHP. The next step after the MHP installation is called commissioning. The MHP will be tested to ensure that all MHP components work well. Commissioning must be performed by independent technicians and not by suppliers. After that, a management structure is decided on and established by the community. This is generally a democratic process, and the management structure typically consists of 2 operators, 1 accountant, 1 secretary and 1 manager. The operator's job is to operate the power plant and perform routine check on MHP components. The accountant's job is to manage fee collection from the community. The secretary's job is to record all administrative activities. And finally, the manager's job is to ensure coordination within the management team and review that all work is done timely and professionally. Management team members should receive training to allow them to perform their responsibilities well according to established MHP standards. In order that the MHP operates smoothly, the community is expected to pay a fee for electricity services. The amount is determined by MHP management. This does not only allow for saving funds for maintenance and operational expenses, but also ensures that electricity is valued and that the MHP can be expanded to benefit more households and businesses. The fee amount can be based on consumption or number and type of appliances, or be a fixed monthly fee. Customers who do not pay regularly should be penalized according to rules established by the management team. These rules must be communicated clearly to the customers and strictly adhered to. Electricity should be used efficiently and electricity wastage should be avoided. Overload can cause interruptions in the power supply. Use electricity efficiently by using energy-saving lamps and turning off appliances when not in use. MHP is a good option to ensure energy supply in remote areas without PLN coverage. This environmentally friendly technology is reliable and can be used to develop the local economy, improve education and skill levels, and encourage community independence. Let's develop the village using electricity from MHP.